LDAP, an abbreviation for Lightweight Directory Access Protocol, stands as an open, vendor-neutral, and widely accepted application protocol that facilitates the access and management of distributed directory information services across an Internet Protocol, IP, network. Directory services, a core component in the development of intranet and Internet applications, enable the sharing of vital information concerning users, systems, networks, services, and applications across the network. An exemplary instance of directory services comprises a well-structured set of records, often organized hierarchically, like a corporate email directory or a telephone directory listing subscribers with corresponding addresses and contact numbers. The genesis of LDAP can be traced back to a group of telecommunications companies well-versed in directory requisites after decades of producing and maintaining telephone directories. This expertise led to the conceptualization of directory services within the realms of information technology and computer networking, ultimately culminating in the elaborate X500 specification. Initially, X500 directory services were accessed through the X511 Directory Access Protocol, DAP, which operated on the Open Systems Interconnection, OSI, protocol stack. LDAP emerged as a lightweight alternative protocol devised to access X500 directory services through the more straightforward and commonly used TCP/IP protocol stack. The initial design of LDAP drew inspiration from existing protocols such as Dixie and Directory Assistance Service, DAS, with the protocol later evolving into what we now know as LDAP. The protocol began as Lightweight Directory Browsing Protocol, LDBP, in its early stages of engineering, subsequently growing in scope beyond mere directory browsing and search functionalities to encompass directory update operations. The protocol earned its lightweight moniker due to its diminished network overhead compared to its predecessor, DAP, making it more feasible for implementation over the Internet owing to its modest bandwidth consumption. LDAP's impact extended beyond its own scope, influencing the development of subsequent Internet protocols, contributing to advancements in X500, XML-enabled directory, XED, Directory Service Markup Language, DSML, Service Provisioning Markup Language, SPML, and the Service Location Protocol, SLP. Moreover, LDAP forms the foundation for Microsoft's Active Directory, showcasing its enduring presence in various technological applications and services. The ADD operation entails the insertion of a new entry into the directory server database. When a distinguished name in the add request already exists in the directory, the server will not add a duplicate entry, but will set the entry already exists result code in the add result to decimal 68. LDP-compliant servers do not dereference the distinguished name transmitted in the add request to locate the entry and ensure that the distinguished name and all attributes adhere to naming standards. The entry to be added must not exist, and the immediate superior must exist. In the authentication process, the LDAP session initially sets to anonymous until the bind operation is executed to establish the authentication state. The bind operation can utilize simple bind or SASL plain to authenticate users by sending the user's DN and password, which should be encrypted using Transport Layer Security, TLS, due to the plaintext transmission. Successful bind requests change the authentication state of the session, while unsuccessful ones reset it. Search operations involve specifying the base object, scope, filter, attributes, size limit, and time limit to search for and read entries within the LDAP directory. The compare operation checks if a named entry contains a specific attribute with a particular value. The modify operation allows clients to request changes to existing entries, requiring the DN of the entry and a sequence of changes, such as add, delete, or replace. Clients must ensure modifications comply with access controls enforced by the server. Modifying the distinguished name of an entry involves move, rename operations, with support for renaming entire directory subtrees in certain servers. Extended operations permit defining new functions outside the original LDAP protocol, with Start TLS being a significant extension establishing transport layer security. Abandon requests the server to abort an operation by message ID, while unbind terminates a session by closing the connection and abandoning outstanding operations. The LDAP URI scheme provides a format for identifying LDAP resources including host, port, DN, attributes, scope, filter, and extensions. The directory schema governs the structure of the directory information tree, DIT, and determines the types of information the server can store, including attribute syntaxes, matching rules, object classes, and more. Server operation is quite flexible, with implementers and administrators making key decisions. The setup can cater to various scenarios, as data storage methods, such as flat files, databases, or serving as a gateway to another server, are not mandated. Access control lacks standardization, allowing different models to be used, including storing user passwords within entries or elsewhere. The server retains the autonomy to deny certain operations and set different limits. LDAP's extensibility allows for defining new operations, introducing controls to modify requests and responses, creating new search scopes, defining bind methods, and attributing options affecting semantics. Vendors have integrated LDAP into various services, adapting data to LDAP X.500 models, albeit with varying degrees of conformity. Some software permits accessing SQL databases via LDAP, despite the protocol not being inherently suitable. X.500 servers may also support LDAP. Moreover, data stores unrelated to LDAP are sometimes migrated to LDAP directories, like storing Unix user and group data accessible through PAM and NSS modules. LDAP is widely utilized in authentication and authorization by different services. For instance, in Active Directory, Kerberos handles authentication, while LDAP manages authorization. An example of a data model within LDAP is the GLUA schema, utilized in distributed information systems, leveraging LDAP to facilitate the discovery of services in a grid infrastructure. LDAP servers can issue referrals to other servers when unable to fulfill requests, requiring a structured naming system for LDAP entries to locate servers containing specific distinguished names, DNs. DNS server records can serve as an alternative method for discovering LDAP servers for an organization. Two common naming styles persist in X500 and LDAP v3, outlined in ITU specifications and IETF RFCs, with one based on countries and the other employing a domain component model.